Walkthrough tutorial on BIDS Lead-DBS. We have now implemented a BIDSified version of Lead-DBS, which means that the way the data is organized and accessed in Lead-DBS will change. The main goal of this tutorial is to acquaint you with the new changes and also show how you can use your old dataset with the new version of Lead-DBS. So to begin with, maybe we can spend a minute talking about BIDS. BIDS, or the brain imaging data structure, is a data structure format for neuroimaging and behavioral data, which is simplified and intuitive to both users as well as developers of scientific software tools, specifically in the neuroimaging domain. While there is no specific proposal for DBS data from BIDS, we have attempted to develop a middle ground which we hope will work well for both users and developers. The main structure which is proposed by BIDS is the presence of these three data sets, which is the source data, the raw data, and the derivatives folder, and the presence of a data set description.json, which, as the name suggests, is a JSON file describing the data set. Now let's go in through each of these folders in more detail. Now the source data folder contains inside it the subfolder, which is the subject subfolder. Inside the subject subfolder is the Dicom files. So in this example here, there are Dicom files, but technically source data is supposed to contain any raw data which is unprocessed and maybe even directly from the scanner, for example, which cannot be used directly by the software tool but contains a lot of header information. This is largely untouched by the software tool itself, except for maybe a step where the Dicom files are converted to Nifti. So if you run DCM to NII, for example, that should convert the Dicom files inside this subfolder into raw Nifti files. Now these raw Nifti files are inserted into the raw data folder. So the raw data folder also has a subject folder inside, and inside the subject folder is the bifurcation into two sessions, that is the preoperative session and the postoperative session. Inside the preoperative session, there is the ANAT folder, which contains all the ANAT files. So this includes the T1 weighted, T2 weighted, there can be multiple T1s, multiple T2s, FGATIA PD, as was always supported by classic Lead-DBS, but they all exist now inside the ANAT folder of the raw data main folder. And the post-op, as usual, would contain either CT or MRI images. The next folder is the derivatives folder. The derivatives contains the main output from the processing tool. The first level of the derivatives folder is the Lead-DBS folder. So if you run some other pipeline which is also BIDS compliant, for example fMRI prep or even lead group for that matter, will dump all their data into another folder at the same level as Lead-DBS. So inside this Lead-DBS folder, you have the subject folder, and inside the subject folder, you will notice that there are various subfolders. Each of these subfolders reflect the steps that happen in Lead-DBS. So it starts from co-registration, normalization, brain shift correction, reconstruction, etc., etc. So maybe let's begin with pre-processing, since it is the first step that happens. The pre-processing is just a copy of the raw data with extremely minimal processing done on it, which includes maybe reorientation, sampling, and also bias field correction. And that is inserted into the pre-processing folder, and all the data that is used to run the rest of the pipeline is obtained from this pre-processing folder, so the raw data remains untouched by Lead-DBS. Let's also take a look at some larger step, for example normalization, which is further divided into 4 subfolders, that is ANAT, checkreg, log, and transformation. The ANAT contains all the Nifti files, the checkreg contains PNG files and other format files or image format files, which are used for checking the quality of the registration, and then log will contain the log files, transformation, Also a specific note on the file name. So you can see that the file name itself has changed. Initially inside the normalization folder would be GL and NAT, for example, but here the file name is more bidsified. The anatomy of a BIDS file name is the presence of various tags. So here it is the sub tag, space tag, and then rec tag, description, desk tag, and a sessions tag. Each of these tags contain a value associated with it. So here it is the subject tag has a value of Dicom legacy, which is the name of the subject, and then the space tag is MNI 152, which is the space of the particular file. The rec stands for reconstruction algorithm. This tag is not obligatory in every single file name. It is used here because another additional step of tone mapping has been done to the post-op CT, and therefore it is used to describe the file. And desk is the description, so that here is preproc, which means that this particular file has been obtained from the pre-processing folder. And then the session is of course post-op, modality is CT, etc. So this should give a good overview on the data structure and also file name. This was a quick overview, so a more detailed description would be included in a manual, so you can always look at that for specific details. So maybe now we can actually go into the practical steps of running Lead-DBS, the BIDS version of Lead-DBS. So let's assume that you are now in the develop branch of Lead-DBS. So the BIDS version of Lead-DBS is hosted in the BIDS branch. In order to access the BIDS branch, you can use your Git manager or terminal. So I will be using a terminal here, and you can go into Git checkout BIDS. So this will take you to the BIDS branch, and once you click enter, and then you can pull all the new changes by using git pull. If you have a smart git or the GitHub desktop application, then that should also be pretty straightforward to do. Once you've pulled all the new changes, you are up to date on the BIDS branch, and there are a few configurations that you have to do to move from your develop branch to your BIDS branch. This includes backing up your preference files and also changing your space folder from the MNI_ICBM to MNI 152. So in order to do that, we've created a script which is called EA switch to BIDS, and when you run that script, you will back up all your recent patients, the EA prefs file, and also update your Lead-DBS search path. Another important point to note is that if you are working with ongoing project, it's always a good idea to make sure that you have a backup of these projects. The BIDS branch, while it is tested, it is still in a beta version, and therefore it is always a good idea to have a safeguarded copy of your ongoing projects that are of importance. In order to explain some of the old dataset types that you may have, I have a few different test datasets here, which includes raw Nifti, and then raw files, which includes both Dicom and raw Nifti files, and then a legacy dataset containing both Dicom folder as well as the classic Lead-DBS files such as this, which you might be familiar with if you've used Lead-DBS before. So let's start with the raw Nifti files. So this here is gzipped, so it has a nii.gz, but you can also use just a .nii extension. So I will simply drag my data set which I want to be converted into a BIDS compliant version directly into Lead-DBS, and that will open a dialog box saying raw dataset with Nifti files only detected, and would you like to migrate it to BIDS? So I say yes, and this opens another application which is called Lead Import. The application already goes through your input data set and decides whether to migrate or to convert the Dicom data to Nifti and Nifti to a BIDS compliant data set. Migration is an option for migrating your classic Lead-DBS into a BIDS compliant data set. And this is of course automatically decided, but if you want to have user control over this, you can also do that by checking and unchecking both the checkboxes. And then you select your output directory, and now you can run this. Great. So after it's run, the Lead-DBS directly loads the patient into it, and you can see that it says raw post-op CT is found. Please co-register to pre-op MRI first. So that's good news. Lead-DBS has already loaded our old data set into has already converted our old data set into a BIDS compliant version and loaded it for further processing. So let's also take a look at how our output data set looks like. So initially, just to refresh you, we had a data set that looks like this, which contains T2 weighted F-Gator CT and a T1 weighted image. So if you go to the output data set, you can see that there's a raw data set containing a subject folder inside. And then inside the subject folder is the preoperative session and the postoperative session, and the ANAT has a T1 weighted, T2 weighted F-Gator, and the postop has the postop CT. And the derivatives contains the preferences. So you will notice that there's a prefs folder which contains the user specific preferences for this particular machine. So now that we've worked on the raw Nifti files, let's look at how you can import raw files along with Dicom files in them. We follow the same steps as we had initially. So we drag your old data set into Lead-DBS. It will open a dialog box which says that Dicom folder is found, and it will run Dicom to Nifti conversion. And then you open the Lead import app, and this now, as you can see, both the boxes are checked. So both the classic Lead-DBS migration to a BIDS data set as well as converting the Dicom data to BIDS compliant data are both checked. And in the output directory, and then now you can run this. So you will now notice that the Dicom files are being converted to Nifti images. This is now the new Dicom to Nifti to BIDS conversion app. On the left panel, you can see that there is information about the files, and on the right panel is a 3D viewer that gives you images of the particular file. If you want to see how another file looks, for example, this is the post-op CT file, you can just do that by clicking on that particular file. The bottom panel here shows how the BIDS dataset will eventually look like. You can include multiple T1 or multiple T2, multiple files of the same modality by separating them using a unique acquisition key. So in this, I'm going to say that the acquisition is a sagittal acquisition. So I edit that by double clicking on this field and writing sag. And so now I'm able to import both of these T1 files. Otherwise, you will not be able to import two T1 files of the same acquisition type. So another interesting component of this is the lookup table. So this lookup table is a mapping or is a dictionary between what keywords are present in the raw generated Nifti files and what type, session and modality they are mapped to. So here initially, if there is a Nifti file containing the keywords T1 MP range, they are usually mapped to the T1 weighted modality, and the session is pre-op and the type is a NAT. If you want to change this and say no, any keyword of T1 should map to a CT, for example, then you can double click and edit that, and you can save it, and this will be saved in your UI preferences file, that is the machine preferences, so that the next time you perform the Dicom to bits conversion, your algorithm will remember that anything with a T1 and MP rate should be converted to CT instead of T1 weighted. We click on OK, we're happy with the changes, and as was before, the newly imported subject file is directly loaded to Lead-DBS, and the messages are also the very similar messages. Let's also take a look at how our output data set looks. So this looks a bit different from when we had only the raw Nifti files without any Dicom files. So inside the source data is the Dicom information, so the Dicom files will all be stored inside the source data. The raw data is now containing the pre-op and the post-op and NAT files, and which contain all the T1, T2 and the FGate tier which we selected in the Dicom to bits conversion app. And there's also the presence of a legacy raw data. So this usually happens when you have both raw Nifti files as well as Dicom files. So the raw data that is generated from the Dicom to Nifti and Nifti to bits conversion is inserted into the raw data folder, whereas the Nifti files that were already present in your classic Lead-DBS file is inserted into the legacy raw data folder. While they have the same structure and maybe even have copies of the same data, they may also have different or more data in one folder than the other. For further processing, Lead-DBS will only use the raw data files and not the legacy raw data files. And the post-op session will have again post-op CT. The derivatives, since we don't have any derivatives, will only have a prefs folder which contains the UI prefs and the description and the raw images description.json file. The third example that I wanted to show here is the presence of a classic Lead-DBS file or a legacy dataset. So if you are, as mentioned before, familiar with Lead-DBS, then you would know that these files are specific to the classic form, and if you want to convert it to the bidsified version, we again perform the same steps. So we drag the dataset into Lead-DBS, and another dialog box is open which says old dataset is detected, will you migrate it to bids? So you press on yes. The lead import tool now opens and the input dataset is already loaded. And then I run it. So once this is over, you can see that again it is directly loaded into Lead-DBS, and normalization has been done and reconstruction is found. So in this case, let's take a look at our output data set. So it only has two folders because there were no Dicom files. So it contains raw data set, which is the pre-op and the post-op. And then the derivatives folder will now be full, and it will contain all the small subfolders. So this should give you an overview of how to use Lead-DBS given different dataset types. As a last example, I would just like to show how Lead-DBS now deals with multiple datasets. When you try to open multiple datasets in Lead-DBS, you will be met with an error. Because multiple datasets are not supported for direct direct loading into Lead-DBS. Instead, you would have to use the lead import tool as a standalone, for which you go to the command line and you type lead import, and then you select your patients the same way that you would while loading it into Lead-DBS GUI. And then you select the output folder, and this should allow you to run multiple data sets multiple data sets and convert them into a BIDSified format. So once the process has been finished, we now have our results dataset, which contains source data, raw data, legacy raw data, and derivatives for both the patients. We can now load this into Lead-DBS by dragging the output directory into Lead-DBS, and this should give you the patients to choose, and you can select them. So 2 patients have been loaded in and multiple patients are chosen is the message given by Lead-DBS. So this should give a good overview of what you could do with your old data sets. And if you have any further questions, you can always reach out to us in the Slack channel. Thank you so much, and see you soon.